Hey everyone, and welcome to The Explainer. I am so incredibly thrilled to have you here today. Look, we're unpacking a really fascinating reality about the tech world right now, and it's this. Building a successful project means you are going to be pitching at absolutely every single stage. Honestly, it doesn't even matter if you've written the most elegant code in human history. If you can't pitch it to investors for capital, pitch it to users for traction, and importantly, pitch it to developers to build an open source community, well, that code just isn't going anywhere. And as we're going to see, once you finally hit that massive scale, you've got a whole new challenge, securing it against the very AI tools that helped you build it.
So let's start right here. Take a look at this framing question. What does it actually take to get the world to care about your code? We kind of have this romantic idea of engineering as this solitary, heads-down pursuit, right? But building in a vacuum is basically a guaranteed path to failure. You have to win people over at every single stage of growth. You're constantly having to translate your technical reality into a value proposition that matters to whoever is sitting across from you. Maybe that's a VC, maybe it's a stressed out end user, or maybe it's a talented developer who's just looking for a cool new project to contribute to. So here is our roadmap for today's explainer. 1. Pitching for capital. 2. Pitching for traction. 3. Attracting open source contributors. 4. Structuring for collaboration. And finally, 5. Securing the scaled project. Let's dive right in. Section 1. Pitching for capital. Winning over investors in 3 minutes. Okay, picture this. You're stepping into the insanely high-stakes environment of a Y Combinator demo day. As a founder, you have an incredibly brief window to convince investors. I mean, look at this timeline. It seems terrifyingly short, right? 3 minutes total. But honestly, this strict constraint is absolutely a feature, not a bug. It forces absolute clarity. You literally get 30 seconds to define a really painful problem, 40 seconds to pitch your elegant solution, 20 seconds to prove the market is massive, 40 seconds to show you're actually growing, and then 30 seconds for a crystal clear ask. Remember, these investors see dozens of pitches a day. This timeline just ensures founders get their vision across efficiently without drowning everyone in technical jargon. So the real make or break moment is what you actually put in that 40-second traction window. And let me be super clear. Vanity metrics like total registered users or your follower count on social media, they do not work. Literally anyone can inflate those. Instead, investors want the concrete stuff, real evidence of product market fit. We're talking monthly recurring revenue, active user growth combined with high retention, or hey, if you're pre-revenue, things like enterprise letters of intent and validated waitlists. Basically, they're looking for an undeniable trajectory showing that people actually want what you're building. All right, section 2. Pitching for traction, demonstrating the product to users. Okay, so you got the capital. Awesome. Now you have to pitch your next big audience, your users. And the massive challenge here is hooking them immediately without forcing them into some tedious 45-minute discovery call. Which brings us to the golden rule of product demos. The sources capture it perfectly with this quote. People buy outcomes, not features. When a user lands on your site, you have to show them exactly how you make their world better, right from the jump. Honestly, they don't care about your complex machine learning backend. They just care if you can solve their specific pain point today. To actually pull this off, the sources highlight the SUPA demo methodology for creating interactive product demos. It boils down to 3 simple steps. First, capture. Record the workflow natively. Second, write. But here's the trick. Annotate around the benefit of the step. Don't just narrate what they're already looking at. And third, polish. Blur out the sensitive data. Oh, and here's a massive takeaway from the material. Never, ever gate your demo behind a lead form right up front. Just let users play with it. Let them experience the value immediately so they actually want to sign up. Moving right along to section 3, attracting open source contributors, building an authentic GitHub community. Now let's pivot to the audience that developers usually struggle with the most, other developers. If we're being honest, traditional marketing usually feels pretty cringy to this crowd. As you can see in this comparison, trying to force an open source community into existence by spamming Discord channels or firing off unsolicited DMs is a terrible idea. It completely alienates people. Instead, the sources emphasize building in public. When you promote authentically by writing a tech blog about a gnarly bug you squashed, live coding on Twitch, or speaking at conferences, you organically attract passionate developers. You find the people who actually resonate with your vision and what to build right alongside you. Once you've got their attention, your GitHub repository has to do all the heavy lifting. This is how you successfully invite developer contributors in. Your open source repository is literally a pitch deck. You need a crystal clear README that serves as an actual, usable how-to guide with step-by-step installation instructions. You absolutely must establish a culture of kindness using a strict code of conduct. And crucially, you need a detailed contributing.md file. A good contributing guideline removes all the guesswork. It tells them exactly how to report bugs, how to open pull requests, and what style guides to follow. It proves that you actually respect their time. And if you want to know how to truly seal the deal with a new contributor, this is it right here. Applying the label Good First Issue to specific tasks in your repository is just a brilliant act of empathy. It sends a massive signal to a newcomer saying, hey, you don't need 5 years of legacy project knowledge to jump in and help. By completely removing that friction of onboarding and putting a spotlight on accessible tasks, you make it so comfortable and honestly so rewarding for someone to make their very first open source contribution to your project.
Section 4. Structuring for collaboration. The architecture of scale.
Okay, so you've pitched investors, you've captured your users, and you've invited this thriving community onto your GitHub. What happens next? Well, we have to talk about the underlying codebase. This slide outlines what an architecture of scale actually looks like, specifically looking at a production-ready template from vStorm for full-stack AI agents. Look, when you have multiple developers jamming on complex AI apps, they cannot be bogged down by basic setup issues. Utilizing a structured pattern, like decoupling fast API routes from your business logic, adding secure JWT authentication, and having log-file observability baked in from day one, solves those massive infrastructure headaches. It frees your maintainers up to focus entirely on the business logic and collaborating seamlessly.
Finally, Section 5. Securing the scaled project. Protecting your product from AI threats. But listen, scaling up brings some intense new dangers. When your collaborative AI product successfully scales, it can actually fall victim to its own automation. Take a look at this number, $47,000. According to forensic analysis from Clyris, that was the annualized cost base of a single runaway AI agent. It was just designed to run some database migrations. But when it hit a roadblock, it didn't just stop, nope, it got stuck in a 4-hour and 47-minute loop, creatively running 38 different migration scripts over and over and over again, just rocking up these massive API charges. And the cautionary tale here is just wild. During that entire 4-hour loop, all the health checks passed. The status reports were green across the board. Like the source says, working as designed is the scariest status. The AI was just being persistent and creative, doing exactly what it was prompted to do. The major takeaway for us is that you simply cannot fix this with better prompt engineering. You just can't. The real fix requires hard infrastructure limits. We're talking circuit breakers and hard cost bounds to physically stop these autonomous systems from spiraling completely out of control. So this table distills the specific vulnerabilities found in scaled, multi-tenant SaaS environments, and it gives us the actionable blueprints to protect them. To kill those runaway loops, you definitely need step limits. To stop one tenant from accidentally or maliciously poisoning the data retrieval of another tenant, you have to use cryptographic tenant tagging. You've got to protect your APIs with Redis rate limiters, and you absolutely must sandbox your servers so external tools can't mutate and attack your host system. Now, if you're sitting there thinking, okay, this sounds like a theoretical risk, it's really not. The sources highlight some pretty alarming real-world examples of what happens when security scales poorly. In one case, an Anthropic Claude Code coding agent accidentally surfaced sensitive local API keys right out of a developer environment just because it had broad file system access. In another, entirely separate instance, an AI support platform for Sears Home Services ended up exposing huge volumes of internal technician and customer records, all because of misconfigured back-end access controls. The fallout from not securing your integrations is incredibly severe. And finally, we have this data from the Trace Safe Benchmark study, which reveals a totally counterintuitive finding. Look at how the accuracy actually remains stable, or even goes up as the number of trace steps increases. You would totally assume that as an AI agent takes more steps in a long, complicated task, it would get confused and its security performance would just tank, right? But the data shows the exact opposite. It proves that the real bottleneck for agent security isn't the length of the task at all. It's the structural competence of the system that's monitoring it. Which brings us to the end of our journey today, from sweating through a 3-minute pitch for capital to building out an open source GitHub community, all the way up to securing massive scaled AI infrastructure. And I really want to leave you with this final provocative thought. When your AI agent faces an edge case it simply cannot solve, will your infrastructure step in and stop it? Or is it just going to blindly fund its next wildly expensive, destructive experiment? Honestly, it might be time to go audit your projects. Thank you so much for joining me for this explainer. I really hope this helps you build better,